Hello and welcome to this virtual session. We're glad you can join us today. Before we get started, there's a few housekeeping items we'd like to go over with you now. Firstly, you can resize the webinar windows to cater to your viewing preferences. You can maximise, minimise and drag the windows to your preferred viewing size. If you look at the bottom middle of your screen, you can click on the widgets that you'll need to get the most out of this virtual experience. Secondly, Microsoft specialists are on hand to answer your questions in real time. So feel free to type in your questions using the Q&A window and we'll answer them as soon as we can. Lastly, we've provided some additional resources for you to supplement your learning. You can access them by clicking on the links in this section. Without further ado, I'll hand over to our speakers.
Hi there and welcome back to Microsoft Azure Virtual Training Day on Microsoft Azure Data Fundamentals. We will be taking it to the next level with 3 new sessions. In session 4, we'll explore the fundamentals of data analytics. I'll show you why large-scale analytics matter, and we'll talk about data lakes, data warehouses, and even data lakehouses. These tools are critical for making sense of massive amounts of data, and I can't wait to show you how they work. Then in session 5, it's all about real-time analytics. We'll dive into how streaming data works, and how real-time analytics allows you to capture and react to insights as they happen, giving you immediate results. And finally, in session 6, we'll wrap things up with the art of data visualization using Microsoft Power BI. I'll show you how to transform raw data into actionable insights using compelling visuals that help you tell a powerful story with your data. So let's talk about large-scale data analytics. Imagine you're building a complex custom-designed bookshelf with secret compartments for your living room. You have all sorts of tools and materials: wood, screws, nails, glue, paints, and finishes. To craft this beautiful piece, you need to follow a plan and use a variety of techniques. This process is similar to constructing a large-scale data analytics solution. In data analytics, we deal with different types of data, formats, and sources, just like you have different materials for your project. One of the first steps is gathering your materials. In data analytics, this is called data ingestion. You collect data from places like transactional systems, files, or even real-time streams, much like gathering all the wood, screws, and nails you need for your project. Before you can start assembling, you need to prepare your materials. Maybe you need to cut the wood, sand it down, and measure everything carefully. In data analytics, this preparation process is called ETL, extract, transform, and load. It ensures your data is ready for analysis. Whether you're working with large batches of data or real-time data streams, this step is crucial, just like properly measuring and preparing your materials. Once your materials are ready, you need a workspace where the assembly happens. In the world of data analytics, this workspace could be a data warehouse, which acts like a fully equipped workshop with specialized tools, or a data lake, more like a large storage area for your raw materials. Sometimes you might use both, combining the best of both worlds in a hybrid setup. Just like you'd follow detailed blueprints when building your bookshelf, data analysts and scientists use data models to guide their analysis. These models act as your blueprint, helping you understand how different parts fit together, making the analytical process more efficient and effective. Finally, after all the hard work, you present the final product. In data analytics, this step is called data visualization. Analysts create reports, dashboards, and visualizations that reveal key insights, trends, and important business metrics. It's similar to stepping back to admire your beautifully finished bookshelf. It's not only functional, but also visually impressive and tells a story. Building a piece of furniture requires careful planning, the right tools, and attention to detail. Similarly, building a large-scale analytic solution demands a systemic approach and the right components. With everything in place, you'll be ready to unlock the full potential of your data and gain valuable insights. Whether you're building furniture or crafting a data solution, having the right tools and plan makes all the difference. Now that we've explored the steps involving preparing and analyzing data, from gathering it through ingestion to transforming and loading it into a workspace, let's dive into how these processes actually get powered. Just like a chef needs the right kitchen equipment to execute a recipe perfectly, your data processing needs the right engines to handle the heavy lifting of crunching through massive volumes of information. In data processing, having the right engine is crucial for efficiently managing and analyzing large volumes of data. These engines handle essential tasks such as data ingestion, transformation, and querying, and they're designed to operate in distributed architectures. One of the foundational tools in data processing is the relational database. These databases are like well-structured recipe books, reliable and organized. They've been around for years and are widely used for data-related applications, including large-scale analytics. Relational databases excel at processing structured data, often using SQL queries. For instance, if you're working for a financial institution and need to analyze transaction data from millions of customers, relational databases allow you to efficiently filter, aggregate, and analyze those transactions. This helps uncover patterns and trends such as potential fraud or investment opportunities. However, as data volumes grow and become more diverse, especially with unstructured data or semi-structured data, more flexible and powerful tools are needed. This is where distributed processing engines like Apache Spark comes in. Apache Spark is an open-source framework designed for handling massive datasets, making it highly scalable and versatile. Spark distributes workloads across multiple worker nodes, which makes it highly effective for complex transformations and queries. One of Spark's strengths is its ability to handle both batch and real-time processing. For example, it can process streams of social media data, such as tweets, posts, and comments, helping organizations analyze trends, identify customer sentiments, and respond to shifts in real time. These capabilities are invaluable for companies looking to make informed decisions, improve marketing strategies, or enhance customer engagement. So whether you're working with structured data in a relational database or handling large-scale diverse datasets with distributed processing engines like Apache Spark, the right data processing engine plays a crucial role in managing data efficiently and driving valuable insights. As we've explored how engines like relational databases and Apache Spark power through data processing, it's important to remember that the data itself needs somewhere to live, organized, accessible, and scalable. The way we store data is critical to how efficiently we can analyze it. Now, let's shift our focus to the different ways we store and manage data, each suited to specific types of workloads and data. Think of a data warehouse like a perfectly organized supermarket. Every item is placed in specific aisles and sections, making it easy to find exactly what you're looking for. In the data analytics world, a data warehouse functions similarly. It's a type of relational database designed specifically to store data in a way that's optimized for analytics instead of day-to-day transactional operations. Here's how it works. Data from various transactional systems is transformed and denormalized into a structured format. This structured schema is like a detailed store layout where central fact tables contain numerical data and dimension tables represent entities that allow the data to be sliced and diced. For example, imagine you're running a chain of restaurants. Your sales data could be organized in a facts table, and aggregated by dimensions like menu items, location, or time. This schema is often called a star schema because it radiates outwards from the fact table to the related dimension, like a star. Now let's compare this to data lakes, which you can imagine as a vast storage warehouse for a construction company. In this warehouse, materials aren't meticulously organized like in the supermarket. They are stored as they come, ready to be used in all sorts of projects. A data lake works similarly. It's a place to store data without needing a rigid structure or predefined schema. It typically uses a high-performance distributed file system to store large volumes of raw, unstructured, or semi-structured data. For instance, imagine you're managing a video streaming platform. You're collecting data on user preferences, viewing habits, reviews, and even metadata about video files like subtitles or formats. This data doesn't fit neatly into a traditional structured format. In this case, a data lake allows you to store all these different types of data in their raw format. When it's time to analyze the data, you can apply a schema on read, meaning you can organize the data when you need it. Technologies like Apache Spark or Hadoop help dynamically process and analyze this data. But what if you need the benefits of both a structured system and the flexibility to handle raw data? That's where data lakehouses comes in. Imagine it as a modern garage with neatly organized toolboxes for specific tasks, but also space to store larger, more versatile equipment. A data lakehouse combines the flexibility of a data lake with the structured querying capabilities of a warehouse. It stores raw data like a data lake, but introduces a relational layer that organizes this data into tables, allowing you to use SQL for queries. Let's say you work for a logistics company, handling vast amounts of tracking data, vehicle telemetry, and customer orders. A data lakehouse allows you to store all this raw data while still providing the ability to run structured queries on specific data sets like tracking customer deliveries or analyzing vehicle performance trends. To recap, data warehouses are like well-organized supermarkets designed for structured data and efficient analysis. Data lakes are like a construction warehouse offering flexibility for storing unstructured or semi-structured data. Data lakehouses act like a modern garage combining the best of both worlds, allowing for flexibility while keeping data organized for analysis. Each storage solution serves different needs, from structured analytics to handling diverse data. Now that we've explored different types of data storage solutions, data warehouses, data lakes, and data lakehouses, and how they serve distinct needs, let's shift our focus to the cloud services that power large-scale data analytics. When it comes to handling large data workloads, platform as a service and software as a service offerings provide the necessary infrastructure to manage, process, and analyze data efficiently. Let's start with PaaS. One of the key PaaS offerings in Azure's analytics ecosystem is Azure Databricks, a cloud-based platform built on Apache Spark. Azure Databricks is designed to handle large-scale data engineering, data science, and machine learning workloads, all within a distributed framework. Think of it as a flexible workspace where you have all the tools to manage complex analytics, but with the scalability to handle even the largest data sets. For example, imagine you work in the automotive industry, analyzing vast amounts of telemetry data from connected vehicles. Azure Databricks makes it possible to process and transform this data quickly, enabling you to run advanced analytics to predict maintenance needs or improve vehicle performance. Its ability to integrate with other Azure services like Azure Data Lake Storage and Power BI allows you to build end-to-end analytics pipelines, giving you insights into driver behavior, fuel efficiency, or engine performance. What sets Azure Databricks apart is its collaborative capabilities. It offers an interactive workspace where data engineers, data scientists, and analysts can collaborate in real time using notebooks. This makes it easier for teams to explore data, share insights, and develop machine learning models together. And with built-in support for Spark, Azure Databricks ensures fast processing across massive datasets, making it a strong solution for both structured and unstructured data. Azure Databricks provides a flexible, scalable environment for tackling complex data challenges. Whether you're working on data engineering, building machine learning models, or processing real-time data, it provides the tools and infrastructure to manage the entire analytics process efficiently. It's ideal for organizations that need the power of distributed computing and the flexibility to customize their analytics workflows. Before diving into SaaS, let's differentiate between PaaS and SaaS with a simple example. Imagine you're setting up a coffee shop. With PaaS, you're given an empty cafe space and you get to choose how to set up the equipment, furniture, and overall design. You have more control and flexibility, but also more responsibility for setting things up. That's like Azure Databricks, where you have the powerful tools and the flexibility to build your analytics workflows exactly how you want. On the other hand, SaaS is like being handed a fully furnished, ready-to-go coffee shop, complete with everything you need to start serving customers immediately. It's convenient, requires less setup, but you might have fewer customization options. SaaS simplifies operations by giving you everything pre-configured, much like Microsoft Fabric, which is a fully managed service designed to simplify your analytics tasks. So while PaaS solutions like Azure Databricks offer flexibility and control, sometimes you need a more streamlined, fully managed solution like Microsoft Fabric. Microsoft Fabric is a comprehensive SaaS offering that unifies data integration, storage, and analysis in one platform. It simplifies the entire pipeline, from ingestion to reporting, allowing organizations to focus on extracting insights without dealing with complex infrastructure. Imagine you're running an online learning platform with data on student performance, course interactions, and content engagement spread across multiple systems. Instead of stitching together different tools and services, Microsoft Fabric lets you manage everything in one place, streamlining the process and reducing complexity. At the heart of Microsoft Fabric is OneLake, a centralized repository for storing all your data. Think of it as a digital workspace where all your data assets, whether structured or unstructured, are stored and easily accessible. The lake-centric architecture means you don't need to worry about data duplication or siloed systems. Instead, your data is available in one unified location, allowing both data teams and business users to collaborate on projects seamlessly. This setup is especially beneficial for organizations needing a single source of truth for their data. Microsoft Fabric's integration with Power BI makes it easy to create interactive dashboards and reports, enabling decision makers to access data-driven insights without the need to manage separate infrastructure components. Microsoft Fabric and OneLake offer a streamlined SaaS solution for organizations looking to simplify their analytics landscape. By providing a fully managed integrated platform, Fabric removes the complexity of handling separate services, allowing teams to focus on analysis and decision-making. For organizations seeking efficiency, ease of use, and collaboration, Microsoft Fabric is an excellent choice for scaling analytics while minimizing operational overhead. All right, so for this demo, we're going to be doing in Microsoft Fabric. I'm already logged into Microsoft Fabric here. And what I'm going to do is I'm going to switch to the data engineering experience right here. Okay. And in the data engineering experience, the first thing we're going to do is actually create a workspace. I'm going to go to workspaces and I'm going to click on new workspace. I'm going to create a new workspace called DP900, for example. And in the advanced section, I'm going to make sure that my trial is selected so that I can actually create some analytical stores. You need to have at least a trial license for this. And I'm going to hit apply. All right, so this is our new workspace. It's completely empty. Let's create a new lakehouse in here. So for that, I'm going to click on the plus new item and I'm going to search for the lakehouse. Let me see if I can find it. And there you go. This is my lakehouse. I'm going to hit on the lakehouse and let's give this lakehouse a name. I'm going to call this Lakehouse DP900 and click create. And here you go. We have our new lakehouse. It has the table section, as you can see here, and the file section. This is my data warehouse component of my lakehouse, and this is my data lake component of my lakehouse, right? Currently, it's completely empty. You can see I have nothing in there. So let's try to get some data into our lakehouse. So for that, I'm going to go to this Get Data button right here. And I'm going to click New Data Pipeline. And I'm going to call this pipeline Ingest Data. And hit Create. All right. So it's directly opening the copy data activity for me to get some data in here. Here, I'm going to be selecting the sample data option to get some sample data into my lakehouse. So I'm just going to click sample data and I'm going to select this New York taxi green data. And it has only one data set, so I'm just going to select this data set. I can wait for the data preview to load so I can see what the data looks like. Or I can just do that when I have my data already processed in my lakehouse. So let's not waste time here waiting for this data preview. Let's go to the next step. And in here, I'm going to add this to my table section. And let me just do that again. And there you go. And then I'm going to load this to a new table. And I'm going to call this new table taxi rides. Sorry, that has to be an underscore, so taxi rides. And you can see it has already generated some column mapping, so my schema is all good. And I'm going to leave this enable partition unchecked because I do not want any partitions right now. So I'm going to click next. And then over here at the bottom, make sure that I have selected the start data transfer immediately so I can get that data moved into my lakehouse immediately. Let's say no, keep as is and save and run. So now I've created a copy data activity using the copy data guide. And I just have to wait for this data to load. Let's check out and monitor this. I'm just going to bring up this blade and you can see the status of this activity. So you can see it was previously queued. Now it's in progress and soon it will have successfully completed. So I'll give it a couple of more seconds. It's not going to take too long. If you want to monitor this in more detail, you can also go to that activity and it opens up this page where you can see exactly how much data is being read and being processed. So you can see right now it's a little bit slow because it has not read or written any files, but there you go. You have some data coming in. It has read some data from a blob storage. And soon it will have some data written as well. We are moving 291 and 300, 291,300 rows from this source to the destination. Oh, there you go. It's updated. So we actually have 3 million rows right now, not only 291,000. And it keeps increasing because that's the number of rows that it's written. The pace is pretty good. And then you can also see the duration breakdown here, how much time it was spent in the queue, how much time in the transfer, how much time in listing the source, and how much time from reading from the source. All right. In the advanced section, you can see if this was manually triggered or triggered via a schedule. So you have a lot of details here in the activity details itself, right? It says copy data details because this is a copy data activity. So let's close this and I'm going to refresh this a little bit more, taking a little bit of time because it's actually pretty a huge amount of data. So let's give it a little bit and then we'll come back to this once the data has been copied. And there we go. Our pipeline has successfully completed. It only took 11 minutes. So let's go back to our lakehouse. I have it right here. And now what I'm going to do is just click on this refresh button that you see here. This tiny refresh button to refresh our lakehouse now that we have some data in there. And now you can see I have this new taxi rides table, which was not there before. So in order to query the data in this taxi rides table, what I'm going to do is I'm going to switch over to our SQL Analytics endpoint. So every lakehouse comes with a SQL Analytics endpoint. So I'm going to just switch over to the SQL Analytics endpoint. All right, there you go. I do have some extra system tables and query insight tables and information schema tables, but the main table that we are interested in is this taxi ride table. So let's create a new SQL query to query the data. And I'm going to write a very simple statement here. Just going to do a select date name. I want to get the day, for example, and I want to get the average trip distance on each day. So I'm going to just do this with the pickup date time as day. And average trip distance, also another column in the table, as average distance from taxi rides, our new table. And also group by, because I want to get in each group, in each day, what is the average trip distance. So I'm going to just copy this up top here again and just paste it in my group by. There you go. Let's run this query. And there you go. I have the average trip distance for each day of the week in this entire table. Okay, so I have Tuesday, Saturday, Friday, Monday, Sunday, Thursday, and Wednesday. All right. So that you can see how easy it is to query the data warehouse part of our lakehouse. So now let's go to the model layouts. You can see it right here, model layouts. This is where we are going to make sure our new taxi rides table is in our semantic model. What we're going to do is just see if our layout has been properly created, our model layout is properly created, which means that I want to see that my taxi rides table is in here, and I can see that's exactly the case in this case. I have my taxi rides table here. Okay. So the next thing what I want to do is go to the reporting tab and click on new report. This is automatically going to try to create a new report on the default semantic model of this lakehouse. So let's take a look. I'm going to create new report, and there you go. I have my taxi rides table. Now, in order to build a report, it's super simple. I'm just going to select, for example, this line graph. And I am going to add to this line graph the pickup date in the x-axis and the sum of passenger count in the y-axis. And there you go. I have a very simple report created just by putting the pickup time in the x-axis and the sum of passenger count in the y-axis. And with that, we can save this. So I can go to File and save this report. So I'm going to save this report to my DP900 workspace, and I'm going to enter a name for this report. I'm going to call it Taxi Rides Report. And save. All right, there you go. I have created a very simple report, and I can then also go back to my workspace and see I have this report created in my workspace. And with this, we have come to the end of this demo. I'll see you back in the presentation. As we wrap up this session, let's take a moment to recap what we've seen right now. We kicked things off with the fundamentals of large-scale data analytics, diving into key components like data processing engines and various analytical data stores options. Then we explored how PaaS services in Azure can supercharge your analytical capabilities and discussed the game-changing potential of Microsoft Fabric. Now it's time for a well-deserved break of 10 minutes. Take this opportunity to recharge and let all that knowledge sink in. When we return, we'll jump into session 5, where we'll venture into the thrilling world of real-time analytics and streaming data. Enjoy your break. I can't wait to see you back for lesson 5. Welcome back, everyone. I hope you all had a good break and are ready for the next session. We're going to dive into an exciting area that plays a critical role in today's fast-paced data landscape. In this session, we'll be exploring real-time analytics and streaming data, an essential area for organizations looking to act quickly on data and stay ahead of the trends. Let's jump right in. If you remember from our last session, we dove into the world of data processing and how it transforms raw data into valuable insights. What we covered was batch processing, where data is collected and processed in chunks. It's like gathering all your ingredients for a recipe and preparing the meal later, once you've got everything together. It's efficient for large volumes, but there's a bit of waiting involved. But now let's crank up the pace a little bit. Today we're shifting gears to real-time streaming data. This is where data doesn't sit around waiting. It gets processed the moment it arrives. Like you're a barista preparing each cup of coffee as soon as the order is placed. No waiting for the next batch, just fast, on-the-fly processing. Let's take a look at this parking lot example. With batch processing, you'd wait for all the cars to park in the lot before counting them. But with stream processing, you're standing at the roadside counting each car as it enters in real time. This approach is vital when you need to react instantly to changes or trends, like monitoring traffic flow for parking space demands. Real-time streaming data can power real-time dashboards, visual displays that update instantly as new data flows in. These dashboards give businesses the ability to make decisions based on current data, not old reports. Whether it's monitoring stock prices, tracking website traffic, or keeping an eye on sensor data from IoT devices, real-time dashboards provide a live snapshot of what's happening right now, enabling you to make the right decision at the right time. Real-time processing shines in industries that need immediate action. Think fraud detection in financial transactions or live updates in stock markets. And while batch processing works behind the scenes for historical analysis, streaming data is right there on the edge, giving you insights as events unfold. In fact, many modern analytics solutions combine both batch and stream processing. They capture real-time data to give you instant insights and continuously process it for things like filtering, aggregating, trends over time. At the same time, this processed data is stored for deeper, long-term analysis, allowing you to get the best of both worlds. So buckle up, because today we're going to explore how real-time analytics and streaming data keep the pulse of your data constantly ticking. Let's get started. In stream processing, the flow of data is continuous and dynamic. So it all starts with an event. An event generates some data. This could be anything from a financial transaction, a sensor reading from an IoT device, or even a user interaction on a website. Once that event generates data, the next step is critical. The generated data is captured in a streaming source for processing. This is where technologies like Azure Event Hubs or Apache Kafka come into play, capturing those events in real time right as they happen. The streaming source is where we collect all incoming data. Think of it as a starting line for our processing pipeline. Then comes the heart of stream processing. The event data is processed in real time. This means that as soon as the data arrives, it's processed immediately with no delays or batching. Unlike batch processing, where data is gathered and processed later, stream processing happens as the data flows in. Real-time processing is all about speed, taking action the moment something occurs. Whether you're using Azure Stream Analytics, Spark Structured Streaming, or another platform, the processing engine can filter, aggregate, or transform data on the fly. Remember the barista preparing each coffee order as soon as it's placed, rather than waiting for a batch of orders to pile up? What's key here is that the data gets processed exactly once. No matter how many events are flowing in, each piece of data is handled one time, preventing duplicates or reprocessing. Technologies like Azure Event Hubs ensure that every event follows a strict path through the system, so it's processed once before being passed along. The beauty of this approach is that it allows for instant insights and reactions. For example, you could detect a security breach the moment it happens, or update a real-time dashboard with the latest stock market prices. No waiting for the next batch, just live, continuous processing of data as it arrives. Finally, we do need to do something with that processed data. The results of stream processing operations are written to an output or sink. This is where we decide how to handle the results, whether we're storing them in a SQL database, queuing them up in Azure Event Hubs for further action, or displaying them visually in a live Power BI dashboard. So in summary, the first step is an event generates some data. Step number 2, the data is captured in a streaming source for processing. Step number 3, the data is processed exactly once in real time. Step number 4, the processed data is sent to an output or sink. These 4 steps happen continuously and in real time, allowing us to react to events as they occur. Now that we've got the basics down, let's move on to the tools required to implement real-time analytics in real-world use cases. All right, let's circle back to Microsoft Fabric for a moment. We've already talked about how it can quickly ingest and store data. But now I want to show you how you can use Fabric to unlock new insights from that data in real time. Here's where it gets exciting. Fabric uses Event Stream to capture real-time data from streaming sources, and once that data is captured, it can flow into different destinations. Think of it as landing in a lakehouse table or even a KQL database. When you choose to store event stream data in a lakehouse table, it opens up a world of possibilities. You get the flexibility to apply aggregations, run filters, transform raw data into meaningful summaries that align perfectly with your analytical goals. It's like taking raw ingredients and turning them into a gourmet dish that's tailored to your taste. Then there's the KQL database. This is where things get really powerful. With KQL queries, you can perform real-time analytics on your data directly from those tables. The insights? They're immediate, giving you a real-time pulse on what's happening in your data and opening up endless possibilities for instant decision-making. But we're not done yet. Once you've captured that real-time data and it's neatly organized in your tables, you can take it to the next level with Microsoft Power BI. This is where the magic of data visualization comes in. You can create compelling, interactive dashboards that bring you your insights to life, helping you see trends, spot anomalies, and make data-driven decisions in real time. So if I were to sum it all up for you, Microsoft Fabric gives you the power to capture, analyze, visualize real-time data. It's a complete end-to-end platform for turning raw data into actionable insights fast. Let's wrap up this session by talking about one of the most powerful features of Apache Spark, Spark Structured Streaming, its use of data frames, and unbounded data frames. This is what makes working with streaming data so intuitive, especially if you're already familiar with Spark's core functionality. At the heart of Spark's data processing is the data frame, a distributed collection of data organized into rows and columns, much like a table in a relational database. The beauty of Spark's structured streaming is that it allows you to work with streaming data in the exact same way you'd work with static or batch data. In this streaming context, Spark treats incoming data as an unbounded data frame. This means that instead of working with a finite set of data, the data frame keeps growing as new events stream in continuously. It's unbounded because the data isn't a fixed set, but keeps flowing in over time. And here's the magic. Even though the data is live and continuously updating, You can query and transform it using the same familiar data frame operations you'd use for batch processing. You can apply SQL-like queries, aggregation, filters, and even join the streaming data with other data sets. Spark processes the data in real time, keeping everything up to date as new rows flow in. For example, if you're streaming user activity from a website and you want to count how many visits occur every minute, you can run a simple aggregation on the unbounded data frame. Spark handles everything, continuously updating the result as new data arrives. It's just like querying static data, except now you're dealing with a live stream. But what makes this even more powerful is the integration with Delta Lake. Delta Lake is a storage layer that enhances your data frames, adding features like versioning, schema enforcement, and ACID transactions to both batch and streaming data. When you store your streaming data in a Delta table, you're not only ensuring that your data is reliable, but you're also getting the flexibility to combine both real-time and historical data seamlessly. For instance, you could store your incoming streaming data in a Delta Lake table and then run queries that combine both live and historical data. This allows you to analyze current trends while also looking at past performance without having to manage separate systems. And Delta Lake ensures that your streaming data is stored consistently and efficiently so you can always trust the quality of the data. With Spark Structured Streaming and Delta Lake, you have the tools to handle both real-time insights and long-term trends in one seamless workflow. You don't need to choose between batch and streaming. You can combine them for a powerful, unified approach to data processing. Now that we've explored these concepts, let's see it in action. All right. So for this demo, we are going to come back to Microsoft Fabric. And this time, instead of going to data engineering, we're going to go to real-time intelligence instead. Okay, so we're going to go to real-time intelligence. Let me click that experience. And as usual, we're first going to create a new workspace. Let's call this workspace DP900 Real-Time Intelligence, RTI. And let's make sure also that we have our trial license assigned to this workspace. And I'm going to hit apply. All right. To do a little bit of prep, what we're going to do is beforehand, we're going to create a new item here, which is going to be an event house. This is where we're going to actually store our data. So event house DP900, and I'm going to hit create. All right. So this is my new event house. I don't have any data in here, but this is where I have my KQL databases, and this is where I'm going to eventually put my real-time data. All right, let's go back to my DP900 RTI workspace. And now what I'm going to do is, create an event stream. So I'm going to click on New Item again, and this time I'm going to select an event stream. Let's call this event stream DP900, and hit create. All right, so this is what my event stream is going to look like. I have my event stream, which is connected to a source and which is connected to a destination. Now let's create a source for this event stream. I'm going to click on New Source, and I'm going to click on Sample Data. And over here in the new source, I'm going to give the name taxis for the source name. And I'm going to actually select the yellow taxi data that we have here. So I'm just going to select that, and I'm going to add this source. All right, successfully added. We can check out the preview of this source right here in Data Preview. So it'll give us a preview of the data that is being added right now. All right, so now that we've added the source, let's add a new destination. So I'm going to click on a new destination and click on KQL database. And here I'm going to select the data ingestion mode to be direct ingestion. And let's give the data destination a name. So I'm going to say taxi data. I'm going to select the DP900 RTI workspace that we have been using and select the event house that we created earlier. All right. And now we have to actually create or select the destination table. As you can see in my event house, I don't have any destination tables yet. So let's create a new table called taxi data. And let's click next. All right, there you go. You can see it was able to find 37 events. So let's go and click finish. And now it's creating the table, taxi data, it's creating the mapping, and finally it will create the data connection. Once that's done, let's close this window. And you're going to see over here, this is going to turn green right now because now it is going to have some data. So now let's go to the event house itself and refresh my event house. There you go. This has to load a little bit more. Just going to give it some time. There you go. Now it is active. So now I should have some data in my event house. So let's go back to my event house. And let's go into my KQL database. And you can see over here, I have my taxi data table right here. So let's query this table. I'm just going to click on these three dots and query table. And let's see the records ingested in the last 24 hours. Okay. So you can see over here the result of this KQL query. And you can see all the data that has been ingested for the past 24 hours. Now I'm going to make a little change to this KQL query. And I'm going to remove this second part, the where clause. And I'm going to add a summarize clause. So let's see how to do that. Just going to delete all of this. And I'm going to add summarize, pickup count. I'm going to create a new variable here, pickup count. And is equal to count by bin and to date time, the column tpep pickup date time. And I'm going to do that I'm going to bin it for every 1 hour. Okay, so I'm going to count in every 1 hour time frame how many pickups have been happening. So let's run this. And you can see over here, we have the count of pickups in every hour. Okay. So this is a very easy way to query your real-time data or real-time streaming data, which is available in your KQL database, which we have added here through an event stream, right? How cool is that? And this is the end of our demo, all right? So I'll see you back in the presentation. That brings us to the conclusion of Session 5. Let's quickly recap what we've covered today. We started by exploring the difference between batch and stream processing, highlighting how each method handles data differently. Then we moved on to how Microsoft Fabric and Spark structured streaming enable real-time data processing and storage, providing powerful solutions for handling streaming data efficiently. Now we have just one more session ahead, and it's all about something really exciting: creating visualizations in Power BI. This final session is one of my favorites because it's where all the data we've been processing comes to life through dynamic, interactive visualizations. So here's the plan. Let's take one final 10-minute break, and when we return, we'll dive right into our last session of the day. I'll see you back here shortly. Welcome back, everyone. I hope you had a chance to stretch and recharge because we're almost at the finish line of this virtual training day. But don't get too sad just yet. We've saved one of the most exciting topics for last, data visualization. And that means we get to dive into one of everyone's absolute favorite tools, Microsoft Power BI. I can't wait to show you how this incredible platform can bring your data to life and make insights more actionable than ever. Let's jump right into the world of data visualization. A cornerstone of business intelligence and one of the most powerful ways to make data speak. And there's no better tool for the job than Microsoft Power BI. By the way, the BI in Power BI stands for business intelligence because that's exactly what it delivers. Intelligence that drives smarter decisions. Now picture this. You're a data analyst for a retail company and your task is to create an interactive dashboard that tracks daily sales performance across multiple regions. Management needs to quickly see which regions are exceeding targets and which are falling behind. They also need insights into inventory levels and customer trends, so that they can make decisions about restocking or adjusting market strategies on the fly. Instead of spending hours sifting through raw data, Microsoft Power BI allows you to present these insights in clear, interactive visuals. Decision makers can instantly spot trends, identify problem areas, and take action, whether it's boosting inventory in high-demand areas or retargeting marketing efforts where sales are lagging. With Power BI, you can turn raw data into real-time insights, making it easy for leaders to understand the full picture at a glance and make smarter, faster decisions. Your journey begins with Power BI Desktop, your command center for building data models and visual reports. This desktop application gives you everything you need to import data from multiple sources, clean and transform that data, and then organize it into a flexible, easy-to-use model. From there, the fun begins, building interactive visuals that aren't just pretty, but practical. They empower users to drill down, filter, and explore the data at their own pace. Once you've built your reports, it's time to publish them to the Power BI service, a cloud platform that makes your insights accessible to business users across your organization, wherever they are. And while the Power BI service offers some basic in-browser editing, the real creative power comes from Power BI Desktop, where you can have a full suite of tools to bring your vision to life. But Power BI isn't just about creating static reports. You can schedule automatic data refreshes so your data is always up to date. You can also build dashboards and apps that consolidate multiple reports into a single cohesive experience, making it easy for users to access all the insights they need in one place. And the best part, they can view and interact with these dashboards and reports not only in their web browser, but also on the go with Power BI mobile app. Talk about real-time insights anytime, anywhere. Before we jump into more, let's dive into a foundational concept, data modeling. This is where you turn raw data into structured, usable models that power all your reports and visualizations. It's the key to unlocking the full potential of your data in Power BI. Analytical models are the backbone of meaningful data analysis. They allow us to organize and structure data in a way that makes sense for business insights. These models are made up of related tables of data where we define the numerical values we want to analyze, called measures, and the entities we use to break down those measures, known as dimensions. Let's imagine an analytical model that includes a table with sales-related measures, like revenue or quantity sold, and dimensions such as products, customers, or time. With this model, you can easily aggregate sales data across these dimensions to answer key business questions. For instance, you could identify total revenue by customer or track how many units of specific product were sold per month. Then we have the dimension tables, which represent the entities used for aggregation, like products or customers. Each entity in these tables has a unique identifier, and the other columns describe attributes of that entity, such as a product name, a customer location, or even customer addresses. A common dimension you'll encounter is time, which allows you to conduct powerful time series analysis, such as tracking sales growth over months or years. On the other side of this model are the fact tables. These tables store the numeric measures that get aggregated. Each row in a fact table represents a specific event tied to those numeric values. For example, in a sales fact table, each row could represent a sales transaction, with values for quantity sold, total revenue, and the time, and the product related to that sale. Hierarchies let you group and structure data in meaningful ways, allowing you to drill down or roll up for analysis at different levels. Imagine in the product table, you've got a hierarchy where categories contain multiple products. Or in the customer table, a hierarchy that organizes customers by region and city. Similarly, in the date table, you can build hierarchies for year, month, and day. This makes it simple to shift the scope of your analysis with a click, zooming in for more detail or stepping back for a broader view. So how do you build these analytical models in Power BI? Power BI makes it incredibly intuitive. Using Power BI Desktop, you can import data from multiple sources and define relationship between fact and dimension tables. You can also create hierarchies, set data types, and customize display formats for fields to create a robust model for analysis. All of these features allow you to create a dynamic and interactive model that supports your business intelligence needs, ensuring that your data is always organized, accessible, and ready for in-depth analysis. Data visualization comes in all shapes and sizes, and with Power BI, the possibilities are practically endless. You've got a ton of built-in visualizations to work with, plus the option to spice things up even more with custom or third-party visuals. Now, while we don't have time to cover them all today, let's dive into some of the more popular and powerful ones you'll want to keep in your toolkit. Let's start with essentials: tables and text cards. Tables are fantastic when you need to present a lot of related data in a simple, organized way. They keep things clean and structured. On the other hand, text cards are the perfect way to call out those key figures, whether it's a sales total or a critical metric. They make sure the important stuff gets the spotlight. For comparing numbers across categories, bar charts and column charts are your best friends. They make it super easy to see the differences at a glance. Want to track how things change over time? That's where line charts shine, helping you visualize trends as they evolve. Of course, you can't forget the good old pie chart. It's a classic for a reason. Pie charts are great at showing how different categories contribute to the whole, making it easy to spot which slice of the pie is the biggest. Now, if you're looking to compare two numeric measures, say sales revenue versus customer satisfaction scores, there's nothing better than a scatter plot. It's your go-to tool for spotting patterns and correlations between two sets of data. And when you need to visualize data by location, maps are your secret weapon. Whether you're comparing regional performance or tracking customer distribution, maps bring a whole new dimension to your insights. But here's where Power BI really pulls ahead. It's interactivity. Think of it as magic at your fingertips. When you select a category in one visual, Power BI instantly updates all the other visuals on your report to reflect that selection. It's an interactive experience that makes your data come to life, letting you explore and analyze with ease. And the best part, it happens so seamlessly that it feels effortless. I've built it up enough, so let's get hands-on. Let's fire up Power BI and explore these amazing features together. Time to see how these visuals can turn your data into powerful and actionable insights. Okay, so this time we are not going to go into any portal because this is the Power BI session. So we're going to open Power BI Desktop. You should have it installed in whichever machine you want to do this demo in. All right. So I have my Power BI already opened up here. And the first thing I'm going to do is create a new report. Okay, so a new report. So I'm just going to click that. And this is what Power BI Desktop looks like. Okay. And on the main screen that we have here, we have a couple of tabs. For me, the most important one right now, since I don't have any data in this tab, you can see over here, I have my visualizations pane and my data pane. So I don't have any data in here, so I need to get data. So in order to do that, what I'm going to do is click on this Get Data button. And I'm going to select More. And you can see the whole suite of connectors that we have available here in order to connect to different data services or data sources, right? The one that we are going to look at for this demo is going to be the web connector. So I'm just going to select web, and I'm going to select this web API. And I have a URL over here with some data. So I'm just going to copy this and I'm going to paste it in my URL section. Okay. Now for the connection credentials, since this is a public URL, I'm not going to use any authentication. I'm just going to keep it to anonymous. And I'm going to click on Next. And this is a little bit of a preview of this file, which is actually indeed a CSV file, right? You can see that at the end of the URL, it says customers.csv. So if you want to take a look at the preview of the data, this is what it looks like. And what we're going to do is just click on the load button right here to load it directly into my report so that it's available in here. You can see it's working its magic. And now I have a new query here, which is going to be my customers table. So what I'm going to do also is I'm going to rename this to customers. All right. So let's load another table. Let's get some products also. So I'm going to do the same thing. I'm going to go to Home. I'm going to say Get Data. And this time I'm just going to select the web API here. And I'm going to paste the products link. Keep the authentication kind to anonymous. Click on Next. And this is what my products table looks like. And let's load this as well into my report. Let's do the same step and rename this to products. All right. And for a final table, I'm going to get some orders. So let's do the same steps, get data, go to the web API, and then put in my URL for the orders dataset. We'll keep the authentication type to be anonymous and select Next. Again, this is a little bit of a preview of the orders data, and I'm going to select Load. All right, there you go. I have my 3 tables, and I'm going to rename this also to be orders. Great. So in here, I have my customers table, I have my orders table, and I have my products table. Now let's go and explore how to create a data model. For this, I am going to go to my model tab. You can see it right here on the left side. So I'm going to click in there. So here you can see our data model, and you can see that these are created automatically. The relationships between my tables are created automatically. And we can cross-verify if these relationships are created well. So here you can see my customer ID and customer ID are selected, so that's good. And this is a many-to-one relationship between my customers table and my orders table, which is also correct. And then for my product relationship with the orders, also many-to-one relationship coming from the orders table to the products table, also really good. Okay. So now that we have explored the data model, let's go to the orders table itself. So I'm just going to select my orders table. And you can see that my properties blade. And in our properties tab, you'll notice that if there is a table selected, it will give me all that information about that table. So let's go to this revenue column. So if I select a revenue column, now you can see all of my details in my properties tab are actually for my revenue column. So over here, what I'm going to do is I'm going to change the format to currency because it's a revenue column and I want my data to be shown in the format of currency. All right. Now that that's done, what we're going to do also is we're going to create a hierarchy in my products table. Okay. So in my products table, what I'm going to do is I'm going to right click on my category column and I'm going to create a hierarchy. So I'm just going to create a hierarchy. So you can see I have a new hierarchy created, category hierarchy. If I open it up, you can see I have only one column in my category hierarchy. So we need to add another column here. So in order to do that, I'm going to right click on my product name field and I'm going to add it to the category hierarchy. There you go. All right. So now I have two fields in my category hierarchy. Now the only thing left to do here is rename my category hierarchy. So I'm just going to click on my category hierarchy here and I'm going to call this categorized product. There you go. I'm just going to click there and that's going to be renamed to categorized product. Okay. Now let's go to the data view. So you can see over here, I also have my data view. So it's the second tab on the left. So the first one is a report view, the second one is a data view, and the third one is my model view. So I'm going to go to my table view or data view, and I'm going to select my customers table. And over here, I'm going to select my city column, and I'm going to give it a data category. And I'm going to say this city column should be categorized as a city. All right. So let's select that. All right. So it's made that change. And now we are done with making changes to our data model. Let's go back to the report view, which is available right here. And let's start building our report. Okay, but before we build our report, I need to make sure that I have one option enabled to help me create my report. For this, I'm going to go to my File, Options and Settings, right down here, Options. And here under Security, I am going to make sure that I have this enabled. So this is already enabled for me. Just wanted to check if it's already enabled. And with that, I can say OK and close this settings page. And now we can actually start building our report. So the first step I want to do is add a text box. I'm going to add a text box which says sales report. And I'm going to make this a pretty large size. Select the text and then make that to be a 32 font. I can make it bold, right? I'm going to just make the space, it doesn't need this much space. I'm just going to make it a bit smaller here. All right, there you go. I have a title of my report. So now let's start adding some visualizations. The first visualization I want to add is going to be for my categories, my hierarchy that I've created. So I'm just going to go to my products table, and I'm just going to select this categorized product hierarchy. Nothing else, just select it. Okay, it's going to create a table in my report. Now, with this table selected, I'm also going to add my revenue column. So I'm just going to select revenue, and that should add revenue to this table. So you can see I have sum of revenue added here. I'm just going to move this up a little bit so it's right below my sales report column, title. All right. Now this looks like a good table, but what we want to do is change this into a column chart. So I'm going to go to my visualizations and I'm going to select this stacked column chart. You can see it right there. So make sure my table is selected and change it to a stacked column chart. All right. So there you go. I have a chart here. Now, if I want this to be ordered by a specific sorting, I can also do that. So I'm just going to show you all of the data in here. And if I want this to be sorted, for example, according to sum of revenue and not alphabetically according to category, I can just come in here and change that. And now you can see it's sorted according to sum of revenue. And let's also make it descending instead of ascending. There you go. Looks much better. Okay. Now, one of the really cool things about hierarchies is the ability to drill down into more detail. Remember, this is not just category that we have here. This is category from a hierarchy. So I can go down to a deeper level, to the products level as well. All I need to do is go to this, to these arrows here. I have one here and another one here. Both of them take me to the next level. So let's click on the one which has two arrows down. And now you can see instead of categories, I have product names. Right? Cool. We can drill up to go up to the previous level of detail. Okay, great. Let's add another visual to our report. Let's add this time quantity. I'm not going to select. I'm going to just deselect everything. Just select the canvas and add quantity. And category. There you go. I have another bar chart, but this time I want to get a pie chart. So I'm just going to go here to my visualizations library and select my pie chart. There you go. I have a very nice looking pie chart. All right, that looks good. So this is the sum of quantity by category. Okay, so if I select that here, you can see the legend is category and the values is sum of quantity, and it's slicing and dicing it by category. Perfect, looks good. Let's add our last visualization, and this time, without having anything selected, I'm going to select the city column, and I'm going to select the revenue column. Okay, now because we have that option already selected, which is use filled maps, you can see that it's automatically filling these maps for me. Okay, so I can zoom in, I can interact, I can click on a certain point, which will then filter the selection on the rest of my report. I can click out here, I can zoom out, I can select another one. So this is a very, very interactive map that we have here. All right. And I can zoom into Europe as well. So the United Kingdom, we have a lot of data points in the UK. And then I can select, for example, London. And this will give me the selection in the other visuals for London, for example. All right. Okay. So that's a little bit about our maps. And with that, we have created our report. And all we need to do is save our report. So if I go to File and Save, I can save this report locally on my machine, which will create a PBIX file, which I can then make more edits to at a later point. And finally, if I'm happy with this report, I can also publish this report to Power BI service. So you can see that I have a publish button here. Once I am ready with all of my changes and edits, and I feel like sharing this with the rest of my organization, I'm ready to publish this report to the Power BI service. And with that, we have come to the end of this demo. I'll see you back in the presentation. Wow, we've covered a lot of ground in session 6, diving deep into data modeling and visualization within Microsoft Power BI. But let's not forget everything else we've explored throughout this Microsoft Azure Virtual Training Day. In session 1, we laid the foundation by exploring the fundamentals of data. We talked about the different types of data, how data is managed, and the roles that data professionals play in the modern data landscape. In session 2, we took a deep dive into relational databases, learning about their structure, advantages, and how to effectively manage relational data using Azure SQL database and other related services. In session 3, we explored non-relational data services such as Azure Blob Storage, Azure Data Lake Storage Gen 2, and Azure Cosmos DB. We discussed how these services handle unstructured or semi-structured data, offering flexible storage and scalability for various use cases. In session 4, we laid the groundwork for data analytics. We learned how large-scale data analytics solutions, combined with various warehousing techniques and big data technologies, can transform raw data into meaningful, actionable insights. And then, in session 5, we ventured into the exciting world of real-time analytics. We saw the importance of processing streaming data and were introduced to the powerful Microsoft Fabric and Spark structured streaming, which enables real-time data flow and analysis. And now, in session 6, we've taken those insights and shown how Microsoft Power BI can turn them into stunning visualizations, bringing your data to life in a way that makes decision-making faster and more effective. But here's the best part. There's always more to learn. If you want to dive even deeper into these concepts, I highly encourage you to visit Microsoft Learn. There, you'll find a wealth of learning paths, labs, and hand-on practices that will help solidify the knowledge you've gained today and give you the tools to explore even more. And if you're ready to take the next step, consider pursuing the DP 900 certification. It's a fantastic way to validate your expertise in Azure data fundamentals. And it's a great credential to add to your resume. Certification is not only a powerful professional achievement, but also a valuable way to deepen your understanding and grow your career. Before we wrap up, I want to extend a big thank you for joining us today on Microsoft's virtual training day on Azure Data Fundamentals. Keep exploring, keep learning, keep driving toward those data-driven insights that will shape the future. Until next time, happy data crunching and see you soon.